Our universe is a vast and mysterious place filled with wonders that boggle the mind and stretch the imagination. It's filled with billions of galaxies, each one a massive collection of stars, planets, and other celestial bodies. Each galaxy contains billions of stars, many of which have their own planetary systems. But where did it all come from? How did this incredible expanse of stars, planets, and galaxies come to be? Scientists have pondered these questions for centuries, and the answer, they believe, lies in an event called the Big Bang. The Big Bang theory is our best explanation for the origin of the universe. It suggests that the universe began from an extremely hot, small, and dense state. This event occurred about 13.8 billion years ago, setting into motion the expansion of the universe. Imagine something smaller than a pinhead containing all the matter and energy that would become everything we see today. This tiny point expanded rapidly, creating space and time as we know it. From this singular event, the universe has continued to expand and evolve, leading to the formation of galaxies, stars, planets, and ultimately, life itself. The Big Bang wasn't an explosion in the traditional sense, like a bomb going off. Instead, it was a rapid expansion of space itself. Imagine a balloon with dots drawn on it. As you inflate the balloon, the dots move farther apart, just like galaxies are moving apart in our expanding universe. In the first fraction of a second after the Big Bang, the universe was incredibly hot and dense. It expanded and cooled rapidly, and as it did, energy began to transform into particles, according to Einstein's famous equation E=mc². The early universe was a chaotic soup of fundamental particles like quarks, electrons, and photons. These particles were in constant motion, colliding and interacting in a high-energy environment. It was a time of great turmoil and transformation, where the building blocks of matter were just beginning to emerge. As the universe cooled, these particles began to combine. The intense heat and energy started to dissipate, allowing quarks to bind together to form protons and neutrons. This cooling process was crucial, as it set the stage for the formation of more complex structures. Protons and neutrons formed, and then they combined to form the first atomic nuclei, primarily hydrogen and helium. These elements are the simplest and most abundant in the universe, serving as the foundation for all other elements that would later form. This period, lasting for about 380,000 years, is known as the era of recombination. During this time, the universe continued to cool, and the conditions became right for electrons to combine with these nuclei. This is when the universe cooled enough for electrons to be captured by atomic nuclei, forming the first neutral atoms. This process was a significant milestone in the evolution of the universe, as it allowed light to travel freely for the first time. This event released light that we can still detect today, known as the cosmic microwave background radiation. This faint glow provides us with a snapshot of the universe at that early stage, offering invaluable insights into its origins and evolution. Section 4. Echoes of the Big Bang Evidence in the Cosmos. The cosmic microwave background radiation is one of the strongest pieces of evidence supporting the Big Bang theory. It's like a faint afterglow of the early universe, a baby picture of the cosmos. Another piece of evidence is the redshift of light from distant galaxies. This redshift tells us that these galaxies are moving away from us. The farther away a galaxy is, the faster it appears to be moving away, indicating that the universe is expanding. Section 5. The Universe, Today and Tomorrow. Today, the universe continues to expand and evolve. This expansion, which began with the Big Bang around 13.8 billion years ago, shows no signs of slowing down. Galaxies are moving away from each other, and the space between them is stretching. Stars are born, live out their lives, and die, each one going through a fascinating life cycle. They start as clouds of gas and dust, which collapse under gravity to form new stars. Sometimes stars end their lives in spectacular supernova explosions that create the elements necessary for life. These explosions scatter elements like carbon, oxygen, and iron into space, enriching the interstellar medium. New stars and planets are forming in nebulae, vast clouds of gas and dust scattered throughout galaxies. These stellar nurseries are the birthplaces of future solar systems. The future of the universe is still a mystery. Scientists have many theories but no definitive answers. Will dark energy continue to drive the expansion of the universe? Will it continue to expand forever, becoming colder and more desolate as galaxies drift further apart? Or will it eventually collapse in on itself in a big crunch? reversing the expansion and leading to a new cycle of cosmic rebirth? These are questions that cosmologists are actively trying to answer. Through observations and theoretical models, they seek to understand the ultimate fate of the universe. One thing is certain: the universe is a place of endless wonder and discovery. Every new observation and discovery brings us closer to understanding the cosmos. The journey to understand our cosmic origins is far from over. As we continue to explore, we uncover more about the universe and our place within it.